All right, let's zoom in on this. We're getting into trig.
Yep.
Okay. If we draw this thing, sometimes you have to draw these, sometimes you can get away without drawing them.
Yep.
But I'm going to draw this one. It's about a 72-degree angle. That's angle A, angle B, and angle C. So that's 72. That's 35. And that is 21. So, in order to use the law of sines, you have to have one angle and its opposite side. You can't even begin until you have that.
Yep.
Well, at this point, we have two angles, but we don't have the opposite side to either angle. So what do we need to do here?
Is this where you do the equation thing?
Not yet. First, you need to figure out angle C. In other words, whenever they give you two angles of a triangle, they're really giving you three.
Okay.
What's angle C? We know the sum has to be 180.
Yep. So 107. So it'd be 73.
So that's 73. Now we have that critical angle and its opposite side relationship. And what the law of sines says is that the sine of the angle divided by its opposite side, in other words, big C over little c, equals the sine any other relationship. The sine of A over little a, and it's also equal to the sine of B over little b.
Yep.
So we have this. In other words, that is the fundamental relationship regarding this triangle. And if we're trying to solve for little a, which we have to, then this is going to be the sine of 72 over little a. Well, that allows me to solve for little a, right? There's only one variable there.
Yeah.
And I can also say that the sine, I can use the same original ratio, is also equal to the sine of b, which is 35, all over little b. Well, again, I can solve for little b. And once I've solved for little a and little b, I've solved the triangle.
Okay.
And now they say round both sides and angles to the nearest tenth. So you got to make sure you do that. Do you need me to go further here to solve this, or are you good to go now with this problem? We have an hour today. I don't know how many problems are on this page, but if we need to finish it to fruition, let's go ahead and do it. Show me
Yeah.
how to solve that, at least.
Huh?
The thing I have circled in the middle with the check mark,
Yeah.
solve that for A.
Um, are you supposed to put this in the calculator?
Well, yeah, you're eventually going to need a calculator, merely because we don't have any other way to figure out the sine of 73 degrees. That's some
Yeah.
number. And the only way you have of finding that is from your calculator. So
Yeah.
it's definitely a calculator problem, but it's also an algebra problem. Well,
Yeah.
let's go ahead and do the first part. No, you know what? Let's not do it that way. that's going to introduce round-off error. How would I solve this for A? Cross multiply.
Okay.
So you end up with A times the sine of 73 equals 21 times the sine of 72. So
All right.
now A equals 21 times the sine of 72 divided by the sine of 73. And you kind of want to put all that into your calculator in one step, as opposed to solving each one, rounding it off, and then doing it, because you'll have round-off error.
Yeah.
So can you put that into your calculator right now?
So the one which is circled?
At the very bottom. That's what we're solving for, is side A.
It was 20.8.
Okay. Now let me ask you a question. Does that answer make sense in the context of what we're looking at? We can see that the side that's opposite 73-degree angle is 21. Should A be less or more than 21?
Less?
Slightly less. And it is.
Yeah.
Perfect. Now solve for B using exactly the same method.
So would you do B sine 35 equals
Hold on. Cross multiply.
oh, okay. So B sine 73 equals 21 sine 35.
Exactly. So B is going to be 21 sine 35 divided by sine 73. Now, let's go back one. I didn't make sure you rounded that to the nearest tenth. When you solved for A, was it 20.8? What was the next digit?
It was 847.
Okay, so it did round off to 0.8.
Yeah.
Make sure you round this one off properly also. So what is
Okay.
B?
So then 21 sine 35.
And it should be significantly smaller than the other two sides, because
Yeah.
it's opposite the smallest angle of the triangle.
It's 12.59.
So 12 point what?
12.6.
Okay, and that's the answer you want to give. She's very explicit here. Round both sides and angles to the nearest tenth. Okay, let's look at number 2. Still using the law of sines, but this one's a little different. If I look at my triangle, and they said include a diagram, so this is something you need to do. And they give us B is 24. So immediately we have an angle and its opposite side.
Yeah.
Once you have that relationship and you have any third piece of information, you're going to be able to solve the triangle.
All right.
So give me the equation that I can now write. Starting with what you have, the angle and the opposite side.
So sine 24.
No, you always take sines of angles.
Oh, so sine 95.
Ever. Trig functions are of angles. So it's
Okay.
95 divided by what?
Sine 24.
Okay, here, let me write the law of sines. Sine of A divided by its opposite side equals the sine of B divided by its opposite side equals the sine of C divided by its opposite side.
Yep.
That's not hard to remember.
Okay.
Straightforward. Now
Yeah.
apply it here.
So,
Sine of B, I'm starting here because they gave me this one. They told me what the angle was and the opposite side. So I can say the sine of 95 divided by 24. There's my starting problem. Now, we have one other side here, which is side A. So let's figure out angle A.
All right.
So what goes on the other side of this equation, or this equal sign? It's got to be this.
So sine 95.
And we just did that one. So sine A divided by its opposite side, 5.
Oh, okay, yeah.
Okay?
Right. Yeah.
And the reason is now we only have one unknown.
Yep.
That's A, angle A. We know everything else. We have an equation that only has one unknown value. So we can solve it. Now, in this case, we don't particularly want to cross multiply. And you'll see why in a moment. If I multiply both sides by 5, that's equal to the sine of A. And that is a number. So if we want to figure out what angle A is, we take the inverse sine of that number.
Yeah.
So A equals the inverse sine of 5 times sine of 95, all divided by 24. So whatever that is going to be your angle A, rounded off to the nearest tenth of a degree. What do you get? This might be a little tricky to get into the calculator. Make sure you use your parentheses properly.
It's 11.97. 11.98.
Okay, well, that's 12.
Okay.
Right?
Yeah.
In other words, if we're rounding off to the nearest tenth, 11.98 rounds off to 12.0. Now we've got everything but angle C and side C.
Yeah.
Well, that's going to be hard to figure out using just the law of sines, because I got to have one of them in order to use the law of sines. Well, can I figure out angle C all by itself, just right now, with the information we have? Can I figure out angle C?
Yes.
What is it?
So you go to sine. So can you just start from the sine B equation?
I'm sorry.
Like,
what?
Can you just start from sine B over B equals?
No, the next thing you have to do is figure out angle C based on the fact that all triangles have 180 degrees.
Oh, okay, yeah.
So what's angle C?
Angle C is gonna be 73.
Their favorite number. Now that we have angle C, we can figure out side C. Give me an equation. Using the law of sines, how we can figure out side C.
So sine 73, and then over is
Okay, let's go back to the law of sines. It's always the sine of an angle over its opposite side.
yeah.
That's the relationship that's in critical. Within any triangle, that never changes, that ratio. It's the same. No matter
Yeah.
which angle or which side you're looking at, that's always going to be true. So if we're going to start with the sine of 73 degrees, what do we need to divide it by?
Well, you have to divide it by C.
Correct. That's the key. Now, you can pick either other angle because we have both of their opposite sides. Let's go back to the original relationship, sine of 95 over 24.
Okay.
Now, that's only got one variable in it. We can solve for C, and that will complete the problem. So again, when your variable is in the denominator, you kind of have to cross multiply.
So do you go 24 sine 95
No,
over?
cross multiply. Start by cross multiplying.
Oh,
24 is never going to end up next to the sine 95 if we cross multiply.
okay. So 24 sine 73
Okay.
over
No,
sine,
equals, cross multiply these two.
equals sine 95C.
Right. Now solve for C.
Do we have to make that equation with like the -1?
There's
Like
a negative sign here.
No, because in the first equation when we
Oh,
did
yeah. That was inverse, not
inverse.
-1.
Okay, yeah.
There's a difference. Well, I'll get to that in a second.
All right.
We're not dealing
So
with any inverses here.
all right.
I'm trying
So
to solve for C. That's the variable. That's a number. That's a number. So what's C going to be equal to?
well,
It's the left side of the equation divided by what?
divided by 95.
Sine of 95.
Sine 95.
Not 95. They're different. 95 is 95 degrees. Sine of 95 is a ratio. Okay? So in order to come up with this now, you got to put that in your calculator and see what number that gives you. It should be a number less than 24. Or, yeah, less than 24. And greater than 5.
It was 23.04.
Don't like that answer.
0.038.
Notice why I don't like that answer. We have a 95-degree angle opposite a side of 24. And you're saying that that is the same as a side of 23 opposite a 73-degree angle. If that were true, then I would be able to say the sine of 73 opposite 23 equals the sine of 95 opposite 24. I'll bet you that's not true.
Yeah.
So we made a mistake somewhere here. Multiply 24 times the sine of 73,
Yeah.
and then divide the whole thing by the sine of 95. What kind of calculator are you using, Lachlan? Is it an Inspire or a TI-84? Or?
Yeah. TI-84.
Okay.
22.
Is that a guess, or is that what your calculator says?
22.9.
You should be able to do that on a calculator. If you can't do that on a calculator, let's stop and make sure you can figure out how to do that.
I did. It keeps coming up. It came up as 23 again.
Really? Let me do it in my calculator. In fact, let me do it. Hold on a second. Yeah, you might be right. I mean, I don't know for sure. I didn't do it myself. But let me do it in my calculator. I got 24 times the sine of 73 all over sine of 95. Hold on. Problem is, I can't bring up Wolfram Alpha to do it online unless I. I get minus 23. How the heck can I get minus? I must be in radian mode. Do you know if you're in degree mode or radian mode?
I'm in degree.
You're definitely in degree mode, huh? Tell me what the sine of 73 is. Just that number alone.
0.95.
And tell me what the sine of 95 is.
0.99.
Okay. Let me pull this up on Wolfram Alpha, and let's just have a look here. Because one thing about this Inspire is it doesn't tell you whether it's in degrees or radians, so it makes it difficult. So let's see, first of all, let me see what the sine of 30 is. If that's 1/2, then it's in degrees. Good, I'm in degrees. So if I want to do the 24 times the sine of 73 divided by the sine of 95, we'll see what we get here. 23.0 is your answer. My apologies totally. That didn't look like it could make sense, but it does make sense.
Okay.
Even though it just shows you that there's not that big a difference between the opposite sides, even though one angle was 95 and the other was 73. All right, let's talk about inverse stuff for a minute. Because you have to understand how inverse functions work. If we take the sine of an angle we get a ratio, always. By definition, we take the inverse sine of the ratio to get the angle. That's how it works. So if you're taking inverse sines, you're trying to figure out angles. Now, in that one problem, we were trying to solve for an angle. That number 2. We had to solve for an angle. So at one point in that problem, we took the inverse sine of the ratio that we had. But this is an important concept. Know that when you're taking trig functions, you're taking trig functions of angles. Know that when you're taking inverse trig functions, they're of ratios to get angles.
All right.
I'll give you a little example that hopefully will clear things up. You're familiar with this triangle, correct? A 3, 4, 5 right triangle?
Yep.
Well, what have I said to you? Nobody tells you what that angle is. Well, what have I said? The sine of theta, what's the sine of theta equal to? SOHCAHTOA. You can't even begin trig if you don't know SOHCAHTOA.
Yeah.
So what's sine?
What, sine?
SOHCAHTOA.
Yeah.
Tells you what sine is. Tells you that sine is the opposite side over the hypotenuse. So
Yeah.
the sine of theta is the opposite side divided by the hypotenuse. Okay? Now, if I want theta, then I've got to take the inverse sine of that ratio. If you take the inverse sine of 4/5, tell me what you get.
57 degrees.
Correct. In other words, I happen to know that that's 57 or 53 rather, and that's 37. In other words, I know those two angles, but most people don't, because when you learn this 3, 4, 5 triangle, it's not because of these angles. It's because that's a perfect Pythagorean triangle. But if you wanted to solve for these angles, you'd be able to do it using inverse trig functions. In other words, you use inverse trig functions to solve for angles. And that's what we were trying to do on that 3, 4, 5 triangle, was we're trying to solve for those angles. We're not solving for the sides. We got all 3 sides, but in order to solve for this angle or this angle, we can use inverse trig functions.
Okay.
Okay? And that comes into play whenever you're using the law of sines or the law of cosines, because sometimes what you get is, here, let me scroll down on this thing. That was, we did 1 and 2, correct?
Yeah.
Okay, let's look at 3. Not every problem can you solve using the law of sines as the first step. There are a couple of type triangles where you can't start off using the law of sines. You have to start off using the law of cosines. And the triangles are usually, you have all 3 sides, no angles, such as this case. We'll say that's 12, that's 13, that's 20. So side, side, side is a place where you have to use the law of cosines. Another place is where you have one angle, say 40 degrees, and the 2 sides. That one's 8 and that one's 10. Notice that I can't solve for anything with the law of sines there.
Yeah.
I do not have, nor can I over here. In other words, I do not have an angle and its opposite side. I got two sides, but I don't know either's opposite angles. And I have one angle, but I don't know its opposite sides. So
Okay.
this is side, angle, side. This is side, side, side.
Yeah.
Those are the two situations where you have to use the law of cosines as your beginning point.
All right.
Okay? And let's talk about what the law of cosines says. There's three laws of cosines, but they all have a very similar look. In other words, a squared, they start out looking a little bit like the Pythagorean theorem,
Yeah.
only then you have to subtract off these two variables multiplied by one another times the cosine of A, angle A, not side A. So that's one application for the law of sines, but depending on what information I have in the triangle, I can use this one also, and notice the pattern. It's
Yeah.
always the other two variables. And this one's always the cosine of whatever that letter is, capital B. So tell me what c squared is.
C squared equals A squared plus B squared minus 2AB cosine C.
Correct. Okay. So those are actually the three laws of cosines.
Yeah.
And it depends on the situation. Well, in our situation here, I have three sides, right?
Yeah.
So I can pick any of these three.
All right.
And I can substitute what I know. In other words, let's just choose the first one.
Okay.
Well, choose those three sides and fill in everything you know into that equation that I have checkmarked.
All right. So 12 squared equals 13 squared plus 20 squared minus 2 times 13 times 20 cosine A.
Now, if you look at that equation, there's only one unknown, cosine
Yeah.
A. So if we can solve for the cosine of A being equal to a number, and clearly I can do that, then in order to solve for angle A, I'll just take the inverse cosine of whatever number we came up with. Now, can you come up with that number, cosine A? You got to do a lot of arithmetic, but
All right, so
it makes sense to do it.
so 12 squared.
Yeah, that's first step. Go through and do all that multiplication in a separate step. So here, let me do it with you. You tell me what everything is and I'll write it. So 12 squared is 144.
Yep. And then 13 squared is 169.
Plus 400
Then
minus
um
26 times 20 is 52. I believe that's 520. 2 times
yeah.
13 times 20
Yeah.
times the cosine of A. Okay.
Yeah.
Well, next step, add those together. That's 569. Now subtract 569 from both sides. What do you got?
1 second. So on the left side, it would be negative 425.
Okay, now that's equal to minus 520 times the cosine of A Now remember, we're going to isolate cosine of A and then take the inverse cosine of whatever our answer is. Well, to isolate it, I got to divide both sides by minus 520.
Yeah.
So come up with that fraction right there as a decimal. Positive, we can see that. So cosine of A equals what ratio? 425 divided by 520.
0.8.
Okay. Now, if the cosine of A equals 0.8, what's A?
Do I put that into my calculator now?
Yeah, and you want to use the inverse. We're solving for an angle. Capital A is an angle. So I want to do the inverse cosine of 0.8.
Does that mean it's... I'm confused how to put it in when it's an inverse.
Hit the trig function and you're presented with 12 options. Choose sine
Okay.
minus 1.
Yeah.
Oh, except in this case it's cosine. So choose cosine to the minus 1.
All right. And then
And then
0.8.
put in 0.8 inside the parentheses.
36.8.
Degrees. Okay. That's a huge step. That means angle A is 36.8. Now notice we can finish out the problem using the law of sines. And that's always what you do. You start with the law of cosines, but then you have to use the law of sines for the next step. So
Can you continue using the law of cosines?
not really. I mean, I guess you
No.
could, but you never want to. It's always harder. The law of cosines is always more difficult than the law of sines. Watch, I'll show you. In other words, the law of cosines got a lot of junk in it. The law of sines is very simple and straightforward. You take the sine of your known angle, 36.8, you divide it by its opposite side, 12, and we know that has to be the sine of B divided by its opposite side. So the key is to come up with an equation that only has one unknown. So now this is the case where when your unknown is in the numerator, you don't need to cross multiply, you just need to multiply both sides by 13. So sine of B is going to be 13 times the sine of 36.8 all divided by 12. What's that number equal to?
So it's 0.64.
Okay, so that's the sine of B. We're trying to solve for angle B. What's angle B going to equal? What do you use when you're solving for angles?
Inverse.
Okay, so you want the inverse sine of 0.64.
Okay. So sine -1. And then so 39.8.
Okay, so angle B is 39.8. Now, notice that we've got all three sides and two angles. Well, what's the easiest way to finish solving this triangle? You got to have all three sides and all three angles. Could use the law of sines. In other words, I know that that ratio also is equal to the sine of C divided by 20. So I could do it that way. But there's a far easier way to do it. I got two angles out of a triangle. The only thing I'm missing is the third angle.
Yeah. So just 180, find
Exactly.
out of one.
Well, you got to take 180 minus these other two angles, the sum of those other two angles. In other words, you know that all three angles have to add to 180.
So 108.4.
There you go. Now you've solved that triangle. Okay. Let's look at, we got 10 minutes. We should be able to do number 4.
Okay.
And number 4 is the second situation. Remember number 3 was side, side, side.
Yeah.
You use the law of sines to solve that. But you also use it when you have side, angle, side. In other words, if I look at number 4, here's my 135 degree angle, that's B. Well, if I make that A and that's C, they're telling me little c is 7 and little a is 19. Well, that is side, angle, side, SAS. That is the other situation where you have to use the law of sines. Notice why. I have 3 pieces of information, but I do not have a side and its opposite angle. So I cannot start off with the law of sines.
Okay.
I have to use the law of cosines.
Yeah.
Now, given the picture that I've drawn, which of those 3 laws are you going to use?
B squared
Yes.
or B?
No, notice that the one angle we know is B.
Yeah.
So I know this stuff. I also know A, I know C, and I know the cosine of B. So calculating little b is going to be a piece of cake. We've got B squared equals, fill in the rest.
B squared equals,
Using this one right here.
yeah. So 7 squared.
What's A squared?
Oh, 19 squared. So 19 squared plus 7 squared minus 2 times 19 times 7 cosine 135.
Okay. Now, everything on the right side is a number. You can come up with that number.
So 361 plus 49 minus
Just those 3 numbers. When you multiply those 3 numbers together, what do you get?
266.
Now, make sure you get the sign of this right. What's the cosine of 135? And by the sign, I mean the plus or minus sign.
Is it minus 0.70? 0.7 minus
Minus 0.7. Okay. I'm not going to worry about rounding it off to his specifications. What is it? It's minus 7.707,
minus 0.707.
which makes it minus 0.7 if we round it to the nearest tenth. Now, multiply minus 0.7 times 266. We're going to have 410 is the sum of those two. And then I'm going to be adding whatever number you come up with. What's 0.7 times 266?
186.2.
Now add those two numbers and take the square root of your answer. Notice that this is equal to b squared. So b is always the square root of this number that you come up with.
596.2.
Yeah, it's the square root of 596.2. And notice that if you forgot to take the square root of it, your answer, it can't be 596. That's not an answer that makes sense in the context of this problem. It's too big. There's no way that side B is going to be that much bigger than side C or A. So what's the square root of that?
I'm checking right now. 24.4.
Okay, and now let's see if that makes sense. You always want the longest side to be opposite the biggest angle. We do. Okay, now we've got our key relationship. We have an angle and its opposite side. Now, as in all problems where you use the law of cosines to begin with, you finish it using the law of sines. Every single one of these triangles needs you to use the law of sines. It's just a question of whether you use it to start with or use the law of cosines to start with. But even when you use the law of cosines, notice that the first thing it does is gives you a side or an angle, but it gives you that relationship that is so critical. So my equation, I'm just going to immediately start writing the law of sines. The only thing I know is that one. So it's the sine of 135 divided by 24.4 equals what? Remember, at this point, I got two other angles to solve for. I got to solve for angle A or angle C. And once I solve for either one of those, then I can do the easy thing for the last step.
Yeah.
Subtract the two angles that I know from 180 to get the third angle. But this middle step, you got to use the law of sines.
Is it 0.02?
Well, hold on. We didn't finish it. Give me the right side. That's just the left side. That's the sine of angle B divided by side B.
Yeah.
Equals what?
So sine, let's say,
You can pick either one.
Sine A.
Okay, divided by what?
19.
Okay, now you have something you can solve. Now, again, your numerator is where your variable is that you're solving for. So don't cross multiply. When you're trying to solve for a denominator, you need to cross multiply as your first step. But in this one, just multiply both sides by 19. In other words, multiply everything by 19 and that's what you get. Now that's going to give you a number in your calculator. What is that number?
19. It is 0.55.
Okay, now solve for angle A. In other words, you just solve for the sine of A, which doesn't do anything directly to come up with the rest of this triangle. We need angle A.
So then, do we have to do this one inverse?
Yep. You always use inverse functions when you're solving for angles.
33.36.
So 33.4, and that's this one. Now how can you get angle C?
Just minus from 180.
Okay, what do you get?
Minus.
Well, first of all, add the two known angles that you have,
Yeah.
and then subtract that from 180.
11.6.
Okay. Now, does that picture make sense? And whenever I ask that question, what I'm really asking is the smallest angle opposite the smallest side, and is the biggest angle opposite the biggest side, and is the middle angle opposite the middle side? And the answer
Yeah.
is yes to all three of those.
Yes.
So that's how you do it. So we've done a couple of law of sines, and you can use law of sines wherever you don't have SSS or SAS. These are the only two situations where you start the problem with the law of cosines. Any other situation, if I have side-side angle, I use the law of sines. If I have angle-side angle, I use the law of sines. If I have angle, 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 I can't solve it, because that could be multiple different triangles.
All
But
right.
in other words, always use the law of sines if you can use it to start, because it's the easiest thing. It's just the ratio of the sine of an angle over its opposite side has to be constant in
Okay.
that triangle. In other words, there's three of those relationships in every single triangle. That
All
ratio
right.
is the same for all three of them. Laughlin, I will talk to you next time.
All right. Thank you.
You're welcome. Bye-bye.